Before we start, here's the agenda for today. First, we'll be going through the house rules. Next, Shafraz will give an introduction on GCP, followed by a hands-on session on Quick Labs. Then, we will have a break. And after the break, we'll continue with the Quick Labs, creating a virtual machine. And lastly, there will be a Q&A section. So here are some of the house rules. First, please enter your full name when joining this Zoom session for identification and attendance purposes. Also, kindly please mute your microphone to reduce unnecessary feedback, which may be disruptive. And of course, no offensive or rude language to be used verbally or in the chat box. Next, if you have any questions, do feel free to leave them down in the chat box, and we'll be answering them at the end during the Q&A segment. For those inappropriate or sensitive questions, the moderators and speaker have the right to reject them. And finally, moderators reserve the right to remove participants who do not observe the house rules. Now, we'll be moving on to the main segment. So we are very happy and honored to have Shafraz here with us today. He's the Google Cloud Community Manager for Southeast Asia, and he'll be sharing with you guys more about what is GCP. So now I'll pass it on to Shafraz. Shafraz, please.
Hello, can you hear me now?
Yes.
Awesome. So can you all see my screen as well? The screen that I'm sharing?
Yeah, we can see.
Cool. So, all right. So I think we have a bunch of things that we need to cover today. So I think without taking much time, let's directly get down into the training session today. And I'm really happy to be a part of the session. And thank you, Shafiq and the team, for inviting me to be a part of this training session on Introduction to Google Cloud Platform. In this session, we'll have two segments. First segment, we'll talk about some theory pieces of Google Cloud Platform, and then we'll be moving into a hands-on session where we'll be using Quick Labs as a tool to get you to get started with get started with Google Cloud Platform. So that's the sort of agenda that we have. In the end, we can, if you have any questions, you may ask through the chat, or maybe you just can pop in and just ask question as well. Awesome. So I think without taking much time, let me run you through the slides. Awesome. So my name is Shafraz Rahin. As Jia was mentioning, I'm the Cloud Community Manager for South and Southeast Asia. I manage the GDG Cloud chapters and also the Google Developer Expert team, experts on cloud as well. I've been an engineer. I've been developing software, and then I thought, hey, I have a really good passion towards community as well. So I started doing community activities too. And I'm a PCA certified cloud architect, like Google Cloud certified professional cloud architect as well. And if you want to connect with me, you can connect me through LinkedIn, and also follow me on Twitter. Cool. So the session one today is the part where we'll be talking about the theory pieces, and especially I want it to be interactive. So there'll be a couple of questions also coming on your way. The PSB team will be handling the questions as well. So please do keep an eye on the content that I'm presenting today, and you'll be successfully be able to answer the quizzes which will come along the way this presentation. All right. So yeah. So now, first thing first, we should know. Now, when it comes to cloud computing, we all speak about cloud computing. Sometimes we might not know what exactly the road which the technology had to take in terms of to reach this cloud computing era that we are in now. So let me give you a little bit of examples. I'll be using a lot of examples because like theory always is not so much compelling to most of us. You will have to have some theory behind it as well. Okay, so the first wave. Let me talk about the first wave, that where we had the brick and mortar sort of, I would say, the arrangements, the places where you had like large amount of servers, etc. Okay, so this is how it is. Now, back in the day, like back in the older days, there was this time where you use like huge machines to be a part of your server environment. Now, what's a server? Basically, a server is where you remotely store your information or data, and then you fetch it from there, and you will be able to serve your end customers as well. Yeah. Example, let's take an example like during Netscape days. They had this browser, they've been using it, and in terms of reaching a certain website, what they will have to do is they'll have to kind of fetch all this information through a large server which was physically available. Yeah, so this is the first wave. It's called the physical or the co-location. Why was it a problem? Why was it a problem where people had to kind of look at a second wave? Now let's look at an example. Now imagine you are running your own business. You have a website. Yeah. So in order to have this website, in order to have all the traffic handling, what you would do is you will have every document or every web page, every image stored in one of your server environment that you have at your home. So then what you do is then you try to kind of get people to access your server environment where you have at your home. But the second thing that you would know is your website gets popular, and then a lot of people start coming in, and because of the traffic, your the whole server environment might get crashed. So then you would think, hey, yes, I need to have my own server. I need to increase the number of servers. So you bring in more servers to your home, and then you increase more of your network traffic. And then final thing that you would know is your whole room or your whole house is filled with servers, which is not the case. It's not, which is the case, but it's not the ideal case. Because the reason being, now when it comes to the servers, it would be costly, and you need to have all the hardware, you need to maintain all the software patches, etc., etc., etc. So that was problematic. So then what people thought was, in the second wave, hey, how can we virtualize this, or how can we create machine? We have one single hardware piece. Inside that, how can we create more machines, like virtual machines inside that? So that's where we have the virtualization coming in the second wave. Now you have a solution. Let's take the same scenario. You have a website, you have sorted all your data and web pages uh, inside your server, and then the next thing that you know is, hey, traffic comes in, people start using it, and then you have your own server, and then you start increasingly create more virtual environments. Yes, that can actually have lesser lesser problematic situation compared to the wave one, but it also has limitations, because always there will be a hardware capacity which you will reach, right? So from there onwards, from virtualization to cloud. Cloud is not a fancy word. It's someone else's computer that you're using. So now, basically, let's say like Google or any other cloud provider, what they'll have is they'll have large set of servers, and in those servers, you will be able to kind of pay and get server spaces from them. So that's basically the third wave that we are seeing. But especially when it comes to that that was kind of the start of the cloud wave, but now the cloud providers are so much competitive. They try to bring in lots of more capabilities into cloud computing, and we'll have a look at those through Google Cloud as an example today. Awesome. So I think how we came across, how we came about to Google Cloud Computing is clear, and especially now, if you take the same scenario where you had your own websites, it's not a problem. You don't have to worry about any of the hardware requirements. You just can go in online, and then you can kind of spin up a VM, which we are going to do today, and we'll be using different resources like machine learning, data analytics, everything inside a cloud provider, and you only pay for what you use for. Yeah, so that's how it goes. Awesome. So we are clear with that. Cool. So when it comes to even though we are in this, as I said to you before, uh, even though we are using cloud computing, even though we are using cloud computing, there are certain differentiating factors among different cloud providers across the globe. It can be a private cloud provider, it can be a public cloud provider. So in this example, I'm comparing along with um, public cloud providers. So it's mainly if you use cloud computing, you'll be able to reduce your costs and infrastructure costs specifically. Like you can ask if you have any friends of yours, probably working for banks, probably working for government, you can ask them, hey, where are your data stored at? Is it in the cloud or is it on premise, which is the physical location? Most probably they might give you an answer saying, hey, we have data on premise because of the regulatory reasons. So then you can ask a question, hey, how much of money are you spending on those? You can check on that. There'll be a humongous amount of mm, cost that they'll have to incur, and also it's not very easy for them to do capacity planning as well. And the second benefit why Google Cloud is that Google is known for better use of machine learning, better use of data to provide greater services, innovative products to the market. Third is it gives you, cloud company gives you an ability to build um, innovative products very easily, very quickly. So in one of our later slides, we'll be talking about, hey, how are these what are the sort of available option if you don't want to focus on infrastructure, if you don't want to focus on building up a VM, we just only focus on like coding. That's all. If you have to do, what are the type of things that you can do as well? The fourth point, connect with business platform and services and partners. So there are a multitude of business solutions inside Google Cloud Platform. And then if you go and check Google Cloud Marketplace, you will find there are pre-defined or pre-built services that you can just click through and then start using those as well. And finally, to make teams productive and secure in mobile and devices. So security plays a major role in Google Cloud Platform. And I would suggest, if you haven't seen uh, the Google Cloud's the six security layers video, go and check out Google Cloud six layers of security in YouTube. You'll find an interesting video done by one of our developer advocates. That's pretty cool and pretty interesting how they manage the security inside a data center. Nice. So why Google Cloud? And also, this is an important part. Many of you, if it was physical event, I would have asked, raise your hand if you're using Gmail, raise your hand if you're using Drive, Google Drive. So there'll be a lot of people who will be saying, hey, I'm using Google Drive, I have an Android phone, etc. So like if you take a bunch of all these products, we have over 1 billion users for each product currently. So which is a massive scale of users. So in order to handle all this massive scale of users, massive scale of traffic, Google has invested a lot on building our own networking infrastructure, which is also being used for the customers or the users of Google Cloud. So that's really awesome, because the same infrastructure Google is using to serve the customers, to the consumers or the users is already available for Google Cloud platform users as well. All right. So 62, this is a stat actually. 62.9 of companies say that public cloud is more secure than their own data center. So this is a stat. Just keep that in mind, because there's a reason for it. Because due to different regulatory reasons, different countries, different companies will need to have their data stored inside their own servers or data centers. So this is stat where it says 62.9 companies say that public cloud, which means cloud, someone else's computer, it's much more secure to have than their own data center, because that reduce the cost, it increases the operational efficiency, etc. So just a set, just keep that in mind. All right, where does Google fit in? So there are public cloud providers. I don't want to call out some names, but there are public cloud providers you might be familiar with already. So if you take all these public cloud providers and then Google Cloud, you'll find that, hey, there are some interesting products inside Google Cloud. There are some interesting products inside Google Cloud, like the machine learning pieces. Example, if you take Google Photos, there'll be uh, there you find Google Cloud machine learning. If you go and type in Gmail, you would find machine learning over there. You will find machine learning being used in many of Google's products. So by using the same technology, same knowledge that Google had, it's also Google had made available for the public also to use through Google Cloud platform. That's very important. So BigQuery, amazing product, an amazing product. So you might have heard about data warehousing. There are certain products which is being used for data warehousing, and then BigQuery is a analytical data warehouse. An analytical data warehouse. What's an analytical data warehouse? It mainly says when you have all your data sets, when you have all in order to like the data warehouse is not a database, right? Data warehouse is not a data warehouse because it goes through an ETL process. So it goes through an ETL process and it stores data inside this data warehouse. And through this data warehouse, what you can do is you can do analytical programs. You can run analytical programs. You can run machine learning models. Like if you take MySQL, can you run a machine learning model inside that? You won't be able to do that, right? We are talking about petabytes of data can be queried through BigQuery, and it provides you like the required answers or required results a matter of seconds or maximum of couple of minutes, depending on your data size. So BigQuery is a very well-known product. It has evolved through the years, and it recently celebrated its 10th anniversary as well. And another thing is cloud storage. Cloud storage, you might have heard about like cloud storage buckets, GCS, in different names. You might have heard about cloud storage. Cloud storage is an interesting storage. It's a blob storage. um, so where you can save any type of data or information that you want to share. So that's very interesting. It has like different levels in cloud storing, whether you want to have um, like if you want to store the data that you frequently use, you can have a separate type of bucket. If you don't want to have like if you're not using the data so frequently, and there's this different type of bucket. So likewise, cloud storage is also a very interesting product, and it's a key differentiator inside Google Cloud. So what are three key differentiators? Cloud, machine learning, BigQuery, and cloud storage. These are just three examples. And when it comes to infrastructure investments, Google Cloud is very well known for having very high level infrastructure, what you call investments being done. So these three pictures you would see, like we have subsea cables across the globe. There's this amazing picture that I will be sharing in later slide. And the third picture, if you see, there's this shark who's going and biting that subsea cable. That these are like interesting stuff, and you need to make sure all these subsea cables are properly secured and there's no damage, because uh, there's this interesting saying. Uh, so Google's DNS has a 100% availability. It's because if you don't have this availability, internet as we know will be down. So all these things happens through all these subsea cables, where it connects to different data centers across the globe, taking like massive amount of data as well. All right, cool. So yes, so this is picture of the available data centers and zones across the globe. So the ones with so these small points, these small dots that you see are called as data centers. Data centers will have data centers are logically grouped into regions, and then inside regions you will have zones, and then there are pops, point of presence nodes as well. So if you see, there are interesting edge point of presence, because let's take an example now. If you want to have data being delivered very quickly to a user, then you probably will be using a edge location or a point of presence in order to deliver traffic. So this is interesting. And the second one is even more interesting. These are the subsea cables that you would see across the globe, connecting into different data centers, different regions, etc. So there are about 16 subsea cables. Like the interesting part about the subsea cable is that Google name all these subsea cables after a certain uh, uh, scientist, or maybe someone who made a difference in the world. So recently, Google deployed a subsea cable called as the Marie Curie, if I'm not mistaken. There's this latest one. So I think that's pretty interesting. Cool. So these are a couple of stats that you can just run through. There are 24 cloud regions globally, 73 zones, 144 edge pop locations, and 96 CDN content delivery network locations, and then 81 dedicated interconnect locations as well. All right. So can we have the first quiz? Cool. I think the answer to the first question is it's 1 billion users. And then if you go on to the second question, you'll also find the answer to that very easily as well. because we just spoke about it. All right. So I think those quizzes were informative, and if you were paying attention, you will be able to easily understand or easily memorize or recall the answers for those. Awesome. So can we move forward?
Okay, participants, you are required to close the quiz pop-up yourself so that you can get rid of the screen.
All right. Cool. So we spoke about why Google Cloud, the importance of it, the differentiators, etc. Let's quickly run through what is Google Cloud, and then I think we have a bunch of more things to be done today. We have to talk about the lab that we're going to do, and then answer some of your questions as well. So in term from Google's definition, Google Cloud Platform lets you build, host application and websites, store and analyze data in Google scalable and reliable infrastructure. So if you pay attention, you'll be able to store your data, you'll be able to store your files, store your data, and then do different type of activities around it. And then most important keyword here is in a secure and a scalable way. Secure and a scalable way. So keep those in mind. We don't have to memorize any of these definitions. Just know you'll be able to do storing, you'll be able to do analyzing, you'll be able to securely and a scalable way you can host your application. So just keep that in mind. All right, a collection of tools that brings your code to the next level. That's a simple way to keep in mind about Google Cloud Platform. So Google Cloud's mission, that's pretty straightforward. I'm going to skip this slide. Nice. This is where we are going to get real. We are going to get real and talk about different tools inside Google Cloud Platform in a high-level way, and different offerings, and how these will be helpful for your projects. This will be helpful for your academic projects, personal projects. It could be if you're doing any commercial projects. This is how a Google Cloud Platform will be useful for you. So Google Cloud Platform has a bunch of services. Last time when I checked, it has over 160 products. So these are only a very few of those. And if you take Google Cloud, even though if you see like a bunch of products, what Google Cloud would do is it'll segment different Google Cloud products into different families or product families. So compute is one area, storage is one area, big data is one area, machine learning, security, monitoring. It's now called as cloud operations. So likewise, they categorize those into different product families. So today we're going to talk about three product families which is inside the Google Cloud Platform: compute, storage, and big data. Compute, storage, and big data. So now inside compute is mainly so from the name itself you can understand. So compute is mainly where you do calculations, you run logical different environments, or maybe you do activities in order to have your infrastructure going. So that's computing. Storage, pretty straightforward. It's about storing your data. So there we have cloud storage, cloud SQL, cloud data store. Now cloud data store is called as cloud Firestore. The name has been changed. Yes, if you have been using Firebase before, you might have seen there's this Firebase Firestore as well. Yes, the same database is the same database that is being ported over here as well. So it's called a cloud Firestore. and then inside big data, one of our differentiator, BigQuery, and then another differentiator, which is cloud machine learning. And if you take these three product families, there are multitude of more products inside Google Cloud, allowing developers to um, have that flexibility to choose whichever the product that they need to accomplish a certain task. All right. So Google Cloud Platform in compute. So in compute, as I mentioned earlier, it's about running logical activities. It's about doing. It's mainly about doing computations, etc. So there are three products that we have mentioned over here: App Engine. Uh, yeah. So awesome. I think I just received. Yes. Thanks, Shafiq. Thanks for that reminder. I think we can quickly run through this and then we'll have enough time for the lab as well. Thank you for that reminder. Awesome. So compute, App Engine. You might have heard about App Engine, an interesting product, and it's called as a serverless product. Why is it called as a serverless product? First thing that you need to know is throughout the spectrum, now there are certain products that you need to handle most of its elements by yourself, and there are certain products that you don't have to handle the activities of that or underlying infrastructure. Google will handle it. You only need to focus on your code. For such a product, we call that as serverless. It's because you don't have to take care of your server side, because the cloud provider will take care of the server side for you. So such product is App Engine and Container Engine is another different area. If you can remember, if you have heard about Google Kubernetes Engine, in Google Kubernetes Engine, Google Kubernetes Engine is again the container engine. Containers are mainly it's a logical representation of set of environments you have packed together, and you can publish that into a certain environment and start using your code. The containers actually came into picture because some folks would say, hey, this code was running very well, it was successful in my own computer, but when I put it into my server, it didn't work. So in order to address this problem, people introduce something called the containers. You might have heard about Docker. You might have heard about Kubernetes. Kubernetes is basically a container orchestration environment. We can later discuss about that. This is only the introduction. Compute engine is basically the bare metal environment where you can build your virtual machines, like the bare metal things, the ones that we discussed during the road to cloud computing. Those type of ones you can create with compute engine. So if you take from App Engine until compute engine, App Engine, you don't have to take care of infrastructure, and it slowly increases towards compute engine, where you will have much more activities that you'll have to handle from your end itself. All right. So I think we can skip the quiz 2 for the moment because of the interest of time. Later probably we can come back if we have time for the quizzes. Just keep it in mind, it's going to be based out of the slide that I showed you. And then compute engine, I mentioned about these activities that you can do. Static and dynamic addressing, high performance, local SSDs, pretty interesting, cool stuff. Just go and check it out about compute engine. There are documentations, very user friendly. And then container engine is mainly about Google Kubernetes engine. And the third one, App Engine. This is an interesting one because if you don't want to start with a virtual machine, you might want to try out App Engine because you only have to focus on your code. And even if you don't really want to focus on some of the activities inside App Engine, you can directly go into Cloud Functions, But in cloud functions, the thing is, it's mainly based on a trigger. So if X happens, trigger the Y function. If A happens, trigger the B function. Likewise. So that's how it goes. If you want to check that out as well. And the second set of product family is storage. There are cloud storage, cloud SQL, cloud data store. Cloud storage is the one that I mentioned earlier. That's also called GCS, Google Cloud Storage, and Google Cloud Storage Bucket. These are some of the terms that you would see when you are doing the labs. Cloud SQL, again, it either can be a MySQL instance, or it can be a PostgreSQL instance spinned up in the cloud. But it has its own limitations because like if you take MySQL itself, there are it has its limitation in terms of scaling, scaling up and down, things like that. So, but if you want to try out things, if you don't have much of traffic coming in, if you don't have much of data, so Cloud SQL will be a good option. And Cloud Data Store, an interesting data store because it can have it says it it's a very high performing database, and it's costly as well. And it's mostly being used by like high performing applications when you want to store and retrieve data very quickly and efficiently. All right, so that's storage. So I want to show across a couple of products inside Google Cloud before we move on to the final product family, which is around data analytics or big data. So there are interesting products, like I mentioned to you, like if you want to bring in and store data inside a cloud storage, not a cloud storage, inside BigQuery, you need to go through a ETL process. So in order to make sure the ETL process would happen, Google has provided tools for those. So to bring in data, you have Cloud PubSub, data transfer service. Okay, let's take a scenario. You have bunch of data. You want to bring those in to Google Cloud Platform. What you can do is you can use Cloud PubSub. If you have streaming data coming in, you can have Cloud PubSub, or maybe if you have like a bunch of data that you want to put those inside the Google Cloud, then you can use data transfer service, and there can be like there can be IoT, Internet of Things devices across, and you want to bring in data from them. And then if you want to have like if data transfer service cannot accommodate any of the data transfer service, it can also have storage transfer service as well. So that's bringing in data to cloud. So where can you store all this data? So you can store all this data inside cloud storage, or you also can store data in BigQuery. Yes, I mentioned you need to go through a ETL process. That's not a database, but BigQuery also can be used as a database as well. But the thing is, you'll have to make sure the cleaning up process of data has happened already. And in order to manage the streaming data, how data would come in, how data is cleaned up, etc., you will be able to use Cloud Data Flow, Cloud Data Proc, Cloud Data Prep. Cloud Data Prep is an interesting product. Once you insert data to it, you'll be able to kind of clean up data. It has a graphical user interface that where you can do that. Apache Beam is again Cloud Data Flow. Cloud Data Flow is the name that's being used inside Google Cloud for this particular product, but outside it's an open source product under Apache license. So Apache Beam, it's what is called that. And finally, if you want to do in terms of analytics, there are Cloud AI services, TensorFlow. You can have all this data being pushed out to Sheets or Google Data Studio. And underlying that, there are new products as well: Data Catalog, Data Fusion, and Cloud Composer. So those are little advanced stuff. Don't worry, you'll be able to get a hang of it once you start getting hands-on experience. All right. So, oops. Cool. So I think we we covered these areas in a high level way. That's big data. Yeah. So this is what it was. Cloud machine learning engine. Okay. So before we move on to the final couple of slides, I would want to showcase around like the importance of machine learning capabilities inside Google Cloud. Yeah. All right. I'm not sure if you can see my screen now. Screen, can you see my screen?
No, Shafraz, we are still at the PowerPoint slides.
We had the PowerPoint slides, right?
Yes, we are at the PowerPoint slides.
Does it say fully managed storage and database services?
Yes, we are at that slide.
Okay, cool. I think probably my feed, like the video feed, is not visible. That's fine. Alrighty. So let me talk a little bit about Cloud Machine Learning Engine. An interesting product because most of you will be interested. Hey, because machine learning nowadays has become a very highly used buzzword in academia, in all these industries, and specifically in Singapore. We'll see there are lots of data analysts, data engineers, and then machine learning engineers, data scientists are using and working with different type of data to build, train, and serve different type of models. So this is a product which can do that. Cloud machine learning engine will give you sort of access to pre-trained models, which means you don't have to have like tons of data on voice to have a automated voice. You don't have to have bunch of images in order to have a trained model, so that once you upload certain image, it'll recognize the tags, the attributes, etc. So all of these like vision, speech, text, Google has done already. And what Google is doing at the moment is that it has provided all these services as APIs for you to use. These are pre-trained models. Like after this, like if I have time, I'll show you like a very interesting demo. And it's available online as well. If you go and search for Google Cloud Vision API, and it has a small tool where you can upload your own images and see what type of data it can give you. It can give you like it can recognize faces, it can recognize different texts, it can recognize, hey, if there's a background, if it's like a known place, it'll also recognize that. It's pretty interesting. So I would recommend you to go and check it out um, on these pre-trained models. But if you don't want to use the pre-trained models, you can always use your own models. And if you are a person who's not so much familiar with building up all these models, you can directly, what you can do is you can use, there's a tool called AutoML. So AutoML will give you access to uh, a tool where you can upload your own images and build your own custom machine learning models without coding. That's pretty cool. That's pretty fantastic, because only thing that you need to do, you just need to clean up your data and then upload your data into AutoML, and then AutoML will build up different models that you can use for your own applications. Alrighty. So then we spoke about cloud machine learning, fully managed storage devices. I think um, there are certain elements that you'll need to have an idea about managed and non-managed. Fully managed and non-managed, because the thing is managed as in Google will take care of the underlying infrastructure, doing all the updates, etc. Unmanaged means you will have to take care of all of it. So that's the differentiation. So there are certain examples over here where we have cloud storage, app engine, memcache, cloud storage. Likewise, we have fully managed storages and database services inside Google Cloud. Okay, so I think before the final slide, we have an interesting slide over here. Google is known for its contribution in open source. In your academy, there can be students who have been participating Google Summer of Code or Google Code-in type of projects, or maybe different type of campaigns which were available in those, all these type of activities. What Google is trying to do is increase awareness about open source, get people to be part of this open source movement. And then Google itself has very high commitment towards Kubernetes and then TensorFlow as well. So Kubernetes, it has high engagement in GitHub, both of Kubernetes and TensorFlow. If you go and search for Kubernetes and TensorFlow, like if you search for top 10 open source projects or products, you will find Kubernetes and TensorFlow in that list as well. So pretty interesting. If you have time, go and be a part of these open source projects. You might be able to code, you might not be able to code. That's completely fine. Even if you do a small change in a documentation, that will be a huge change for another person who's referring to all this documentation. So go and check out open source projects. So we can skip the quiz 3 as well. All right. Oh my God. All right. What makes Google Cloud different? Best in the class security, hybrid and multi-cloud, fully managed. You will get best in the class embedded AI and machine learning, and best of Google, because this is the same network that Google is using to help out all the customers, the 1 billions of customers in different products. Alrighty, so we are moving into the session 2, which is the hands-on session with quick labs.
Thank you, Shafraz, for the amazing sharing session on GCP. So really appreciate that you take the time to be here with us today. And I believe the participants had enjoyed themselves and had learned a lot from this session. So if you guys still have any trouble like on setting up the labs, you may join our Discord channel where Shafiq sent in the chat. So our members will assist you from there. So now we have come to the end of our session. But before you go, I need you guys to help us fill in the feedback form. It will mean a lot for us, and this will help us to improve on our future events. So I'll give you guys some time to fill in the feedback form. You may click in the link in the chat box that Daniel has sent. Okay, next, I have also some announcements to make. First, I would like to share about our upcoming event, Android Study Jam. So if you're interested in Android, Kotlin, and even app development, do come and join us on this workshop. It is also alright if you know nothing about coding, app development, because this new to programming track is for beginners to learn the basics of programming and how to apply those skills to building basic Android apps using Kotlin. So there are 2 sessions. The first session will be on the 30th of November, and the second one will be on 21st of December. So sign up below or scan the QR code. Yeah, so Daniel has also sent a link on the chat box, so you may check them out. So currently, we are also having the subcommittee recruitment. As you all know, Google has 4 colors: blue, green, yellow, and red. And Google can't be formed without those 4 colors. So just like DSC can't be formed without you and me. So if you wish to contribute and be part of us, do fill in the form in the link below. And when filling up the form, you may need to enter the last 4 digits of your NRIC. Please also note that the recruitment date starts from 9th of November and ends at 19th of November. So all are welcome as long as you have the passion. Also, if you have any questions or doubts, feel free to contact any of our core team members. So lastly, thank you everyone for attending tonight's session. We hope you had enjoyed it and see you again soon in our future events. Last but not least, do check out our social media channels, Instagram, Facebook, YouTube, and LinkedIn, and follow us if you have not yet too. So thank you everyone. Bye-bye.
Thank you. Bye-bye.
Thank you, Shafraz, and thank you everyone for attending the session tonight. Okay, have a good weekend, and if you have any more questions, you can always go on to Discord and ask our core team members if you need any help. Okay, I'll see you guys soon. Bye-bye.
Bye-bye.